Question 2. A cruise ship left the Bahamas 3 hours before a private yacht. So before I even work past that, I just want to think about that relationship. So I've got two boats, and one of them left 3 hours before the other. So one of them is going to be traveling for a longer amount of time. Now, I may have to revise this in context with the rest of the problem, but I think I could go one of two ways here. The cruise ship traveled more time. It travels more time. So I could say this. I could say if the yacht traveled T hours, I probably wanted to use the other color for that. If the yacht traveled T hours, then the cruise ship traveled more. I could say it traveled 3 more hours. So because the cruise ship left the Bahamas 3 hours before a private yacht, the vessels traveled in the same direction. The cruise ship traveled 25 miles per hour, and the private yacht traveled 40 miles per hour. So now I have their speed, and these aren't knots because I don't know what that is. So the cruise ship was slow. It was going 25 miles per each hour. And the yacht was traveling 40 miles per each hour. And by the way, the time here is recorded in hours because it said it left the Bahamas 3 hours before. So these are hours. And one of the things we know is that if we take miles per hour, that's a rate, and we multiply it by a certain amount of hours, right? What we get, hours with an S, what we get, miles per hour times hours, right? You can see that these units cancel, and what I'm left with is this is just miles. So this is kind of one of the ideas that we've known and we kind of intuitively understand, we play with, but the fact that we have a distance traveled in miles equals a rate that you're traveling in miles per hour times time. So distance traveled equals rate times time. So I can come over here and I can say, I'm really curious about when it says the private yacht traveled at what distance from the Bahamas will the yacht overtake the cruise ship, right? So we know that they're going to be exactly equal to each other at some point, and then one moment past that, the yacht would be slightly ahead, right? So what we really care about is this boundary, like when is this distance the same as this distance? When is the cruise ship distance from the Bahamas the same as the yacht's distance from the Bahamas? Using this relationship, we can write a system of equations, right? The distance traveled equals rate, 25, times time, t plus 3. Distance traveled of the yacht equals its rate, 40 miles per hour, times the time. If I wanted to, I could rewrite these by using the distributive property. In fact, I'm probably going to have to do that. So let me rewrite this equation. I'll say distance traveled is 25t plus 3 times 25, which is 75. And I'll write this one again. It's just 40 times t. And we're really concerned about when these distances are the same. So I can just say, let's let the distance of the yacht be this equal to the distance of the cruise ship. Let's let these distances be the same. So I can write 25t plus 75 equals 40t. If I take away 25 from both sides, I get 75 equals 30 plus 10 is 40. 40 minus 25 is 15. 15t. And then I believe 15, 30, 45. I think this is 5. This is 5. I think it's 5. I think 5 times 75. 5 times 5 is 25. 25. Carry the 2. No, that's not what I want. 5 times 15. I believe 5 times 15 is 75. 5 times 5 is 25. Carry 5. Yeah, it is. So therefore, 75 over 15 is t. T is 5. So, and remember, t was the amount of time that the yacht was traveling. So if the yacht traveled for 5 hours, 440 times 5 is its distance, and 40 times 5 is 200. And and 5 plus 3, right, is 8 hours. So if I put in 5 in this equation, 5 plus 3 is 8, and 25 times 8 is also 25 times 8 is also 200. So the answer here is they're going to be right next to each other at 200 miles. And then after that, like, even 1 minute after that, then the yacht would be slightly ahead. So clearly there's a lot of things here. We're talking about average rates. We're talking about distances being exactly equal along the same direction. But when we isolate all that, this is a very simple problem that allows us to write a system of equations and solve that system. Again, this organization tool, distance, rate, time, is never required, but I did want to see that you went ahead and you were able to write a system of equations and you're able to solve the system of equations. So sometimes putting in what we know into this table helps us identify the system of equations and then use that to answer the question.